I'm going to show you how to simulate a passive walker, the rimless wheel. And I guess the trickier part here is that a rimless wheel in 2D is easy to model using MATLAB. By easy, I mean you can constrain it to be in 2 dimensions by writing the equations appropriately, and it will not slip and fall in the third dimension, which is side by side, right? But in CoppeliaSim, it's basically a 3D simulator, and so you need to constrain the motion of the rimless wheel in 2 dimension for it to basically not fall side by side because there's no control. So the lecture, sort of the CoppeliaSim part today, is actually dedicated towards showing you how to constrain the motion of the rimless wheel to be in a plane. Again, this is useful for other things later on. So let's get started. So I'm going to create a 6 link rimless wheel. And the way I like to do it is add primitive shape. Let's put cylinders. Let's make them let's make them slightly longer, about let's say 1 meter. Oh, it scales it. So keep proportions 0.02, 0.02. Okay, so that is, there we have a cylinder. And so this will become our uh, rimless wheel. It'll actually become 2 spokes. If I put the hub in the middle, then it'll become 2 spokes. Now I want the collisions to be nice and smooth, and not have this kinks here, which is basically a cylinder. So what I'm going to do is I'm going to put 2 spheres at the ends. Okay, so I'm going to get 2 spheres. So sphere 1, and I need to make it 0.02. Okay, so it came there, and then copy paste. So I have another sphere. Now all the spheres are sitting here. The trick to getting it to align exactly to the place where you want to align is to actually make them uh, childs of the cylinder first. Okay, now they will be childs, and now you can click on translate, click on position, and go to parent frame. And so now we can move the spheres with respect to the parent frame. So we know that the parent is this, and so we want to place them at zero point 0.5 meters from the center of mass. So I just need to put 0, 0. This should be minus zero point 0.5, I think. Where'd that go? Okay, I think it just went down. We have to see where it is. And then the other one is going to be 0, 0 plus zero point 0.5. No, it should be plus zero point 0.5. Okay, so there it is. So if you want to see it, then maybe I can. Okay, let me just save it somewhere. We call it Rimless um, spherical. I'm going to use a spherical joint with this one. So it's spherical. So if you want to see how it looks, I'm going to take the mouse and then move it in the Z direction. Oh, I moved this. I should move the cylinder. Let me just move in the Z direction. There it is. Okay, so I believe that it actually has the, yeah, it looks like the sphere is already there, which is good. Okay, so that worked. So I was able to attach the sphere to the end. So now it's going to be a nice uh, sort of, instead of being a surface contact, it's going to be more like a point contact because of the spheres. Okay, now I need to have, basically, I'm going to group this up because I want this to be one group. Um, Group merge, group selected shapes. Okay, so it's one object. Okay, so now once I got one spoke, let me create the other. This is actually 2 spokes, not one. I can create the other ones. Just copy paste. copy, paste, and then paste. Okay, there we are. Now let's rotate this by 60 degrees, I guess. Let's see how it works out. Rotation. Uh, I think you need to rotate this about the y-axis. Let's just try that. Oh, hold on, I did an error. I should uh, try again. Okay, just stretch, just put 90. That looks right. So let's just put 60 degrees now. Okay, that looks okay. Let's see if I can visualize this. Yeah, that looks fine, I think. Okay, so let's just try the other one. Rotate. And this one I need to rotate by 120 degrees. Okay, so that sort of looks like a rimless wheel. Okay, now if you want to make it slightly more better, maybe I can put like a hub. So add a primitive shape. I want to add a sphere, sorry, a cylinder. And let's say I want to make it point one is fine. The z dimension, I think it's point 0.2, so 0.05 maybe. Okay. Okay, so first thing I need to move it right in the middle. So I'm going to move it position with the world frame. I need to move it 0.5, I guess. That didn't work. I thought that would, or maybe I need to rotate it next. Let's rotate it first. So rotate by, I think 90 degrees, about the same way as before. No. Okay, that's better, but for some reason it's not the way I thought it should be. I'm pretty sure I made it 1 meter, so it should have been. Okay, so the trick is again make this as a parent. Now click that, go to parent frame, and then say 0, 0, minus 0.5. 0. Okay, that looks right. Okay, so that worked. Okay, now we can start to see how it looks. Looks fine. Looks like a rimless wheel. Okay, so we got the rimless wheel. Now what we can do is we just need to group this thing together. We call this rimless. Okay. Just need to group this thing. Okay, so now if you, it falls down. It's not realistic. Let me put RT, which is real time. Then eventually it falls down. Okay, so it clearly doesn't have stability in the 4-up direction. Let me call this rimless. Okay, so how do we get it to basically be constrained in one dimension? But before we constrain it, let me just rotate it by uh, maybe 10 degrees about this axis, or the axis which is sticking out from the plane of the rimless wheel. Okay, so that way it has opportunity to turn. For that, I think I need to click on rotation, and I need to rotate about the z-axis. So let's make it, it's minus 90, let's make it 100. Okay, that did work. Is it? Sure, this was minus 90. It's fine. Let's just make it 10. Does that work? Okay, so now it's probably the way I wanted. Now when you see if this looks right. Yeah, it looks right. Okay, so when I run it, it clearly falls that time. Okay, let me just move it slightly down so it's contacting the ground. So world frame of the z-axis, and let's go down. I think that's about it. Okay, now it looks more realistic. Okay, we got that. It falls down the 4 half plane. We have no control over the 4 half plane, so we better constrain it. So let's see how to constrain it. So the way we constrain this is, um, first of all, let me resize the floor. If you want to resize the floor, you just move that. So now it's 15 meters on the x, it's 15 meters on the y. And the reason I'm resizing it will be clear in a bit. Okay, now I'm going to move this rimless wheel to the edge of, or rather, a little bit further away so I get more room for my boom, which is the spherical joint. So I'm going to take the rimless wheel and move it along, in this case, y. Okay, okay, let's see how it looks. There's more room, but let it be there. Okay, let me rotate this. Okay, so now what I do is I need to create a spherical joint. I will attach the spherical joint to this, and a spherical joint is basically a joint which allows for rotation about the x, y, and z axis. And in CoppeliaSim, you cannot actuate a spherical joint. It's passive. Okay, so before I can establish a spherical joint and attach it to that to the robot, you cannot attach a spherical joint to the floor. You need to attach it through a mass. So I need to first add a mass. So let me just say a cuboid, a small cuboid, and whatever default is fine. It's sitting right there. Let me just move the cuboid as far as I can along it's the y-axis. Okay, this is good. Now let me add a joint, a spherical joint. So it's the first time we've talking about a spherical joint. I want it to move right on the cuboid. So the trick is to make it as a child of the cuboid. Then click on translate, go to position, parent frame, and now you just want it to be sitting on top. So just make it 0, 0, 0. Okay, so it's sitting there. If you wanted to make it look big, then you can maybe make it 0.1 or 0.2. Okay, now the thing here to remember is that you want to make the cuboid, you should not, okay, maybe I should do this later on. Let us now connect the rimless wheel to the spherical joint. In other words, we make that a parent. Okay, and now let's run this. So you can see that it did not fall in the 4 half direction. That's because it's connected to the cuboid. If you want to make it look like it's working, let's just launch this rimless wheel with a speed along the green, which is, I believe, the y-axis. So this is something which we have done in the past. We have seen how to launch a projectile. We basically initialize the x, y, and z velocity. So it's the same code. Essentially, I'll create a script, insert a new script. Let's call it a non-threaded script. I need to close this because there's a bug. It won't let me associate the object first time. Click on again. Click on the non-threaded script. Let's associate that with the cuboid and close. And now let's modify the code. So what I'm going to do is I'm going to get the object for the rimless wheel. So it'll be rimless is going to be the name of the joint handle. So sim.get object handle, and then I need to tell which object it is. So in here it is called rimless. Okay, and then if you remember, the call to get the initial velocity set is basically sim set object float parameter. So it's a float parameter. Rimless is the object. 3000 is the x velocity, and in this case it is 1 if you want to set it to 1. So I think I need to set the y. So we just copy this 3 times. 3001, 3002 for the y and the z, and then I only need to set that. So let's not mess with the x velocity and the z velocity, and we just set this 5. Okay, so if this is right, then it should move in the y direction, which I think was the green. Maybe I got it wrong. Let's see. Okay, so here I set it wrong. I actually moved it in that direction, so it just moved the whole thing to the right. If you want to avoid it from moving the object, that is, this cuboid has a mass, and since it has mass, it's dynamically enabled, and then it moves to the right. If you want to avoid it from moving to the right, you can just go to dynamic properties and then disable it from being dynamic. It's going to be a static object, so no, how much you push it to the left, right, it won't move. So now if you run this, it's not moving because I fixed that to the ground. It's a static object. The other way to make it not move is to increase the mass of that object to a really large value. So this is like the floor, and the ground will not move because it's massive. Okay, so I created the wrong velocity. So I need to change this from y, I think, to the x, and it will work fine. We call that 5. Okay, you can see it stopped. Stop this. I need to launch it with a higher speed. So how about 15? Okay, let's see. Okay, it fell down, but you can see it's still hung to the cuboid, spherical joint. This is what the spherical joint does. It basically ensures that it is in the line. So it basically fell from the floor because this floor is only so long. So let's stop this. If you want to play with the floor, then you can do this. Let's make it 25 by 25. So it's really big. Okay, I hope it will not fall now. Let's launch it. So eventually it'll come to stop. But what you notice is that the rimless wheel is going in a circle, and that's because it's connected to a spherical joint. So this is a so what happens is, if as long as it's moving in a plane, the face of the rimless wheel is going to be in the vertical plane. If you start moving this rimless wheel on a slope, then you'll see that, or it goes a height h above the ground on a slope downwards, then you see that it actually, the face of it is not perfectly level with the xy plane. It's actually going to be tilted. This is a too fast speed. Let me launch it with a slightly slow speed. Maybe try 7. This might be better. It stopped. Go a little bit closer. Okay, so it clearly stops because it runs out of energy, because every time the foot hits the ground, there's a collision and loses energy. Okay, so that's one way of simulating a constrained walker. You you create a cuboid, which is a small mass, attached to it a spherical joint, and make that rimless wheel or whatever three-dimensional walker you have as a child of the spherical joint, and you'll see that it moves in a circle. So that's one way. Let's do it another way. So I'm going to open a new file, new scene. Okay, and I'm going to take the rimless wheel which we created. So let me, I don't know if I can copy this. Copy, paste. Oh, that works great. Okay, so let me move it, translation along. Let's see, this will work. Yeah, this will work. Okay. And now again, if I let this go, it falls. Okay, so the other way to do it is actually, okay, rimless. The other way to do it is to actually copy this, make another copy, and then let's move it slightly to the left. So the best way to move it is, if you don't want to guess, is to make that a child of the original rimless wheel. Click on that, and I only want it to move along the thing, along the y-axis. So let's say point 1, not this way, 0, maybe this way, point 1. Let's actually more, maybe point 25. Okay, that looks good. So now if you look at it, it looks good. Okay, so I just need to connect the two with a rod. So I will now add a primitive shape. Let's say it's a cylinder. Point 1 is fine. Okay, I need to turn it by 90 degrees. So over some axis, I believe it should be about the x-axis. So about the red. Okay, and now since the distance between this is 0.25, I think I should make it 0.25. Apply 0.25. Okay, now I just need that to go right there. So what I do is, instead of guessing it again, make that a child of rimless, and then I go to sorry, go to translate. See, translate, and then say parent frame 0, 0, 0. Okay, still it's off, so it should be moved to the left, I think, about the z-axis. 0.25. No, that's wrong. How about this? So the thing is, I don't know what the axes are, so that looks right. So it should be 0.5 the other way. 0.25. I think 0.125 because the distance is okay. That looks perfect. So now I have connected the two. You can visualize it. That looks good. Okay, now I don't care. I don't want to make them all parents or child of anyone. So just take cylinder, take rimless wheel 0, and say edit group. Okay, so now we have made a single rimless wheel of consisting of two rimless wheels. Now we launch it. It falls down. Well, let's make it realistic. Okay, that's not surprising. It fell down because there was no velocity, but it clearly didn't fall in the 4-half direction because now it's constrained. Okay, now we can do the same thing we did before. We call this rimless, and then go to my code. Okay, let me create this code. Insert new script, non-threaded. Close that. Run it again. Associate with rimless. Done. Now go here, copy this code. Okay, so I think it should be along the x-axis like here. So zoom out and then launch it. So it fell down. So let's increase the size of the floor. Okay, let's just go max. I think this looks cooler. Okay. I'm just doing it this way because you'll see that it doesn't slip off the ground. It doesn't go in circles, so it's nice. Let's just move it. So it's a runway, so I'm going to move it along the negative x-axis. So let's do this. Translation along the x-axis. It looks nice. Okay, there we are. And now okay, I think we are ready. Aha, it fell down. I think it's something to do with the launch. It's too much speed. or I think it's probably floating in the sky, and then when it falls down, it basically hits the ground, and then it's a closer look. Let me actually launch it from above. Let me just move it along the Z direction. Okay. And now let's see if it's a little better. Yeah, it works a little better. For some reason, I think the way I set it up was that one of the spoke actually is uh, probably the spokes are touching the ground or something weird is happening. So now if I launch them with a slightly higher speed, should all work fine. Make it 10 because of a big runway, and then zoom out. Okay, eventually it falls because it's too much speed. Okay, so that's how you get this thing to go on flat. If you want to do it on a slope, let's just do that and we'll stop. Let's do the same thing on a slope. So what I need to do is essentially make a new file. Where do I save this file? Okay, I know where I saved it. Okay, so instead of modifying so you could do the what I'm going to do with the slope with any of the two files. I'm just going to use the constrained one, the two rimless wheel, because it's easier. Make a copy, and let's call this slope. Okay, and let's open this. Okay, now I'm going to put a slope here and make it go down a slope. So let's just get this. Okay, so the easiest way to make a slope is say add primitive shape plane, and then we want the plane to be I think 25 meters along the x-axis and uh, 5 meters maybe over the y-axis. Okay, so we got the plane. We can just move it uh, to the right along x. Okay, that looks good. Now we want to okay, let's move it back. Okay, we want to slope it now. Okay, so how do we slope it? Well, it's as simple as going to rotation, and then we want to slope it about, I'm going to guess now it's about the y-axis. So let's make it 10 degrees. So it goes up. Okay, now we want to move it up. So along z-axis. Okay, that looks good. Now only thing we need to do is put the rimless wheel on top of the slope. So in this case, we simply we don't really need to launch it with the speed because it's already on the slope. So now we just take the rimless wheel and move it in the z direction. Okay, that's good enough. And then throw it. It just fell through. I think it's because the properties of the rimless of the plane. Let's see, show dynamic properties. Okay, so when we use a plane, you can see it's not dynamic, it's not respondable. Respondable is when it can detect collisions. We want it to be detecting collisions, right? So when the rimless wheel is dropped in, so just enable that. And now run this. It doesn't quite run. Okay, maybe we do want to launch it with the speed. We don't want to go so fast. We can make it maybe 1 meter per second in the y direction. It falls down. I want to change the orientation of this to back to minus 790. I think this is the one I changed. This minus 90.
I was thinking maybe you could also launch it with a z velocity.
Yeah, you could launch it with Z. That's true. Uh, say one. Let's see what happens. So here it'll be hitting the ground. Yeah, there is some problem with the way I'm launching it. It's probably something to do with the reason it's falling is because the the collision is not even on both sides. Something is not perfectly level. Let me move it along the Y, along X. Let's see how is it? Okay, let's move it. Okay, now let me turn this, move it along Y. I think I got it in the wrong direction. I think it should be moved along X. Okay. Yeah, it doesn't quite fall the right way. I think it's skewed. Uh, it's tilted on one side. That's why when it falls, oh, I see. It's being launched with the velocity in the wrong direction. This is incorrect. It should be along X. Yeah. Now it turns and falls, but at least it did not fall off immediately. Let's not launch it with a z velocity. Let's not
That
get.
that's weird because the x is actually perpendicular to the direction of the speed, right? Or
It's
is
world
it with
frame.
respect to the it's world frame.
It's
Gotcha.
world frame. Yeah. This is always world frame. That's the yeah. It's not about the body frame. I think it might be tilted a little bit. The way to check is to do rotation and then I don't know if this has an effect. Minus 90. I mean, the safest bet seems to be putting it in a spherical joint. Yeah, this is better. I think, yeah. So now it fell because of the friction properties of this. You can play with the friction properties of this surface and then it'll behave better. But I think it gets going now. I wonder if it goes without a speed. I think it doesn't work this way. No. Because I bet you that if you try to create this simulation again, you will end up with a different answer. Okay, so might be able to build in SolidWorks, right, and then